Okay, I just wanted to talk about a couple of quick things in Chapter 2, the concept of marginal distributions, conditional distributions, and the concept of independence. So we're typically presented with data in a two-way table that represents two categorical variables and their relationships that they have. So what we're going to do is we're going to take a quick look at these two variables here. This was a survey that I had done during the semester, and two of the questions that I asked folks were whether or not you have a tattoo, and if you were to play rock, paper, scissors, what would you throw for your very first throw? What would that be? Okay. I asked 176 people. Okay. And you can see on the table here how people answered the question. And you could also see that in this table, I put in the row total and the column total. Those are what we call marginal distributions. And it just helps us get some summary information. Okay. Now, we often know that when we're working with counts like that, it's a little deceiving. We'd probably rather be working with percentages. One thing that we can do is we can turn all of the values in our table, all the values, into percentages. And this is what's referred to as a table of percents. You can see that every value was changed into a percent by dividing by the denominator of 176. So you can see 14 divided by 176 gives me my 8%. 79 divided by 176 gives me my 44.9, and so on. Now, they can be a little bit misleading. I want to draw your attention to this column here for scissors. Now, it looks like there's a lot more people, okay, with no tattoo throwing scissors than people with tattoos throwing scissors. Now, if you take a closer look, there's more people in the table that had no tattoo versus the people that had a tattoo. So naturally, we're going to have more people throwing scissors. That's just kind of logical. So it's really difficult to do some good comparisons here. But we could look at overall effects. All right, what's most helpful is to look at a conditional distribution. And a conditional distribution essentially holds one of the variables constant while you look at how the other variable is distributed. For example, this particular conditional distribution that we have over here, all right, is conditioned on the variable tattoo. So no tattoo and yes tattoo. And you'll notice that while everyone's changed into a percent, it's changed into a percentage out of its own total. So here, 29 out of my 146 gives me my 19.9. And 79 out of 146 gives me my 54. And the grand totals now become these 100%. So in this particular case, I can compare my no tattoo people to my tattoo people and how they throw using, again, my conditional distribution. Okay, here's a different conditional distribution. Here I am conditioning based on throw. So you can see here I took all the people that threw paper, all 31 of them, and I said, all right, of those people who threw paper, that's my condition, what percentage of those people had no tattoo? What percentage of those people had tattoos? And I did the same thing for rock and the same thing for scissors. And again, you can see my column totals are now all 100%. Okay. All right, let's talk briefly about this concept of independence or association. From the reading, you gather that independence means that these two variables really have no relationship with each other. They act, again, independently. If they don't act independently, if we think that they're kind of either moving together or there's some sort of a relationship in there, then we refer to that as the variables having an association. So let's take a closer look at the variable that we did in our survey here. So I can kind of pose it as a question. Do people with tattoos, do they play rock, paper, scissors differently? In other words, is there an association between those two variables? Now, this slide might be a little confusing here, but let's take a look at what we've got. We've got our original data here. Over here, we have our data that is conditioned on whether or not somebody has a tattoo. Down here, we have whether or not our data conditioned whether or not conditioned on what they threw. And down here we have our table of percents. Now, the table of percents doesn't take into account the different size or the different number of people that we asked in each category. It's just everybody out of the total. So it's really difficult for me to use that to answer this particular question. Now, the most logical thing to look at would probably be this distribution right here. And this more readily allows me to compare no tattooed people versus my tattooed people. And if there was no association, in other words, if it didn't matter whether or not somebody had a tattoo in how they played rock, paper, scissors for their first throw, then I would expect all of these distributions here to be the same. Now, if you look at the rock column, you can see 54% versus the 46.7%. They're pretty close. Okay, statistically, that's actually pretty close. When I come over to scissors, I can see a huge difference in the scissors. And if I come back over to the paper, I also see a difference here. So I don't expect them to be exact. However, I do expect them to be a little bit closer than that. So it appears that there's an association between these two variables. If I come down to my other distribution down here, where I have conditioning based on throw, I also see different percentages. Now, it's a little misleading here because I'm not necessarily comparing these two against each other. I'm comparing this pair against this total. Okay? So if 83% of the people have no tattoo and 17% of the people do have tattoo, then I would expect the people that throw paper to also be 83 and 17, and the people to throw rock, 83 and 17. And you can see this one's pretty close. Okay? And again, scissors, I would expect 83 and 17. It's pretty far off, and therefore I can draw the conclusion that there is evidence of some association between those two variables. I hope this helped. Okay.